Now what we have here is a gas sensor. It measures CO2 and total volatile organic compounds. It's also temperature compensated. And we go ahead and we hook this up to the Arduino here. There's labels on the board, and then there's labels on this board, just one-to-one correspondence. Now we're going to go ahead and find the library and the code to download this to our Arduino so we can begin detecting total volatile organic compounds inside the atmosphere. So the first thing we'll want to do is go on to the Adafruit website and then figure out what type of library we could use for this thing. Makes programming way easier. In some cases it makes it possible. Some of the stuff is pretty complicating. So here's the sensor we're looking for, and this will be the informational. So it'll have some valuable information in here. We won't necessarily need to go over that now. So it says you got to run the sensor for 48 hours to burn it in, and then 20 minutes in the desired mode after each power up. So we're obviously not going to run it for 48 hours right now, but it's good to know. Okay, so the Adafruit CCS8, this is what we need. So we're just going to go ahead and save that, and then go to our downloads here, get that onto our desktop here, extract all the folder. Now we need to place this into our Arduino library folder, so that'll be found right here. It says libraries. So see, these are all the folders. So we just go ahead and we put that in right in here. Obviously, we are an administrator. All right, now that we have the library, they're going to have examples on here, so we can just more or less run this and open it in Arduino. These companies mostly focus on selling commercial products, not software. So if you don't know how to use the software, then it's kind of silly to have the products in the first place. So that's why they make it incredibly easy. So we have everything we need right here. Now we can go ahead and just verify, just to be sure that we got our libraries where they need to be. All right, now make sure we got our board on here. That should be good. Okay, so let's go ahead and upload it. All right, done uploading. Now you can see this is serial print in. We got a serial monitor up here. We can go ahead and open that and see what's happening. As you can see, we're getting a lot of bad data. That's because our baud rate is 9600 and we have it set to 56,000. So we have to adjust that. Now we have reasonably good data. Okay, so this data, now this is just what it's starting out as. Remember before it said the sensor needed a 48-hour burn-in period. So we're getting proper data here. Now, what we want to do though, is we want to hook this thing up wirelessly. And to do that, we're going to have to hook up a Zigbee shield to the Arduino. And then we'll hook up the a receiving antenna at our computer. So we're going to go ahead and do that and configure our antennas. Let's just So here's our board running. This means the TX and the RX. That's serial information. So what we're going to do is we're going to hook up this shield to this Arduino, and then this will be hooked up in our computer. So this will be wirelessly transmitting to this when this is on the Arduino. So the Arduino and the gas sensor will be wherever they need to be, and then we'll be able to sense this all at our computer. But to do that, we're going to use this device here to configure first this antenna and then this antenna as well. So we need to configure both of these. One will be a coordinator, one will be the router. So let's just go ahead and do that now. To configure Zigbee antennas, we're going to need a type of software called C02. So let's just go ahead and show you how to put it on the computer. So it's a Digi product, not Digi key, just Digi product. So we go ahead and download it. And we are on a Windows system. So go ahead and save that. And it does require a little bit of time, but fortunately we have an abundance of that currently. Alright, now we're getting somewhere. So next to that, next to that. Oh, that should be good. Alright. Alright, so let's go ahead and launch this bad boy. So that particular apparatus that we just showed you, that's hooked up to into one of the USB drives right now. We're going to discover it. So the Arduino Uno, that's what's hooked up to the Arduino, obviously. This is the one that we're going to be configuring. So the pan ID has to be the same for both antennas. Now this antenna is a router, so this portion is disabled. And then the one thing we want to pay attention to is this ID right here, which will become evident in the very near future. So as we get node identifier router 00 there, and the rest of this stuff doesn't really mean a whole lot. So this is already, this is already set up and ready to go. I just wanted to point out a couple of the important factors. We're just going to go ahead and exit out of this and then hook up the other one. Alright, so now that we configured this one, let's go ahead and remove this antenna and then place this antenna on here. And then we'll plug the USB back in. And as you can see, it's under power, so let's just go ahead and configure this one now.
All right, so we're going to have to rediscover our antenna. All right, now you can see there's a few differences here. It says coordinator. You'll notice the pan ID went to 1234. It used to say 0, but then when it updated it, it went to that. So we have the coordinator enabled right there. And the destination address is the FFFFFFFFFF. So the operating pan ID of the router was FFFF. So that's why we have the destination address FFF. So this is the one that has to go on the Arduino. It's sending the information from the gas sensor to the antenna on our computer, to the Zigbee antenna. So this is properly figured, so let's go ahead and close out of this and hook it up to the Arduino.
Alright, so we want to hook this antenna back up to the shield, and then we'll hook the shield. See, there's a little thing right there that hooks up to that. So we're just gonna hook this guy up, and all the coding will pretty much stay the same. So that makes it pretty simple. Now we can plug it in here, and we're under power. Now we have our antenna hooked up to the computer, so we can go ahead and see if this is wirelessly transmitting.
Alright, now to see if we're getting information wirelessly, we're gonna use cool term. Basically a terminal emulator. Alright, so COM5. Now we can see what all the comms are out there. So remember, 4 was the Arduino and 5 was the antenna receiver. So let's go ahead and OK that. And then connect it. And we're at 9600. Alright, so the information is a little different, but it's there. Now we can go ahead and open up the Arduino here. So we can see the actual information being sent out, and then the information being received. So this is the information sent out. See COM4. And this is the information received, COM5. So they should match up quite well, and it appears that they do. So what we're going to go ahead and do now is hook up the Arduino remotely and power it from another source, and then see if it'll still connect up. So let's go ahead and do that right now.
So we have the Arduino in a remote location, and we're just going to go ahead and plug it in and see what happens here. So now it's lighting up, and as we can see, it is transmitting data. So let's just go ahead and see if we're receiving any of this data. So here's the receiving antenna. Now let's head over to the computer here. So now this was the COM that we were working with. So just go ahead and connect that, and as you can see, we're receiving data. So what we're going to do with this is we're going to capture the text file like we've done before, and we're just going to run this thing overnight. once this sensor stabilizes and it does the 48-hour burn-in or whatever, then we should have some pretty accurate values to go off of. So if you want to test the carbon dioxide or total volatile organic compounds in your home, this is an excellent way to do it for a relatively cheap price.